Hello, this is Mrs. Gregory. This is the lesson practice 34 for Algebra 1A students. Now I'm going to be giving you the answers, so please make sure you do these before you watch this video. All right, we're on page 214. We're going to do problems A through H. All right, let me go ahead and give you a picture of the lesson practice, which is right here. All right, and I want you to work on these problems. So take a moment. If you don't have a book, make a picture of this, or at least just hold it here and work out these problems. All right, so let me go ahead and start working on these problems for you, okay? Now, it says determine each sequence if each sequence is an arithmetic sequence. If yes, find the common difference and the next two terms. So let's go ahead and do A and B real quickly. And let me put this here. A and B. The answers are here. All right, first thing we got to do is determine if the sequence is arithmetic. I think I forgot a letter. Put a T. We forgot the TH there. My handwriting is terrible. Arithmetic. All right, forget that. Anyways, go on. If yes, find the common difference and next two terms. Okay, so here's the sequence. 7, 6, 5, 4, and then 3 and 2 weren't there. So we only had the 4, and we had to determine, is this an arithmetic? And to get from 7 to 6, we added a -1. From 6 to 5, we added a -1. From 5 to 4, we added a -1. So in a sense, this is subtracting the same thing, but we're adding a negative. And so therefore, my common difference, D, is equal to a -1. All right, just want you to know my common difference is -1. So therefore, we subtract 1. My next two terms are 4 subtract 1 is a 3. 3 subtract 2. 3 subtract 1 is a 2. These are my next two terms. Okay. All right, let's look at B. We got 10, 12, 15, and 19. So to get from 10 to 12, we added 2. All right, subtracting those 2. 12 to 15, we added 3. And then 15 to 19, we added 4. These numbers are not consistently or constant because they keep changing. So no, this is not an arithmetic sequence because there is not a common difference. All right. That's not terribly difficult, but if you're not understanding the terms, it can be more difficult. All right, let's go on to C. C says, use a recursive formula, and this is the recursive formula, all right, where we have a to the n equals a to the n minus 1 plus d, which we have a term, and we look at the term before it and add the common difference. Okay, so it says use the recursive formula to find first 4 terms. We know that the first term is -3 and the difference is 4. So all we do is we add 4, right? That's all this says. Go to take the one to find term 2, look at term 1, add 4. Same thing here, recursive to get term 3, to find term 3, go to term 2, add 4. So we added 4, and we do that again, add 4. So we found the first 4 terms. I could keep going, but they only said first 4. So these are the first 4 terms of this sequence. Hopefully you got the same. Now D says to use the rule a to the n equals 14 plus n minus 1 times a -3 to find the 4th and 11th terms. So for the 4th term, let me put 11th term here, so at least so for the 4th term, we know that n is equal to 4. And so this is a to the 4th plus 14 plus 3, which is 4 minus 1 times a -3. And we just calculate it. 14 minus 9 equals 5. So the 4th term is a 5. And then the 11th term, all right, is 14 plus 11 minus 1 times a -3. 14 minus 30 gives me a -16. Hopefully that makes sense. Now, if we had to, we could pretty much figure out all these terms and just make them a list, but this rule keeps us from having to make a full list and going through each one of the terms to get the next term. All right, let's move on to E. Hopefully this is making sense. E says to find the 10th term of, this is the sequence, 1, 10, 19, 28. All right, and I would suggest every time you do this, make sure that it is arithmetic. So 1 to 10, the difference is 9. 10 to 19, the difference is 9. And do it every time, because sometimes they're very tricky, okay? They might say find it, and truth is you don't have an arithmetic sequence. But I did find that it was 10, it was 9, 1 to 10, add 9, and that's how we get these. So my D, my common difference is 9, and my first term is 1. All right, so I go ahead and I'm going to make a general, the general equation to find the arithmetic. So a to the n is equal to 1, which is the first term, plus n minus 1 times d. And now I use it. N equal 10. So we're looking for the 10th term. N is equal to 10. So a to the 10 is equal to 1 plus 10 minus 1 is 9 times 9. I end up with 1 plus 81. And so the 10th term is 82. All right. Moving on to F. This is find the 11th term of 2/3, 1, 1 1/3, 1 2/3. And again, look at this and make sure. So if I add a third, I'm adding a third, I'm adding a third. So we find that our common difference, our D, is equal to 1/3. Our first value is 2/3, that's AN, and we know that our difference is 1/3. Here's my general formula. All right, and then I'm going to load in A1 to be 2/3 and my D to be 1/3. So here's my general formula for this sequence. And now I want to find the 11th term. N to the 11th is equal to 2/3 plus n minus 1. 11 minus 1 is 10 times 1/3. We end up with 2/3 plus 10/3, which is equal to 12 over 3, which is equal to a 4. Hopefully you got the same one. I'm hoping this is not too difficult. It's just a lot of letters, and using this formula can seem a little daunting if you don't know what it is. All right, we got 2 more to go, but we use this equation. Again, it's like this. These last 2, G and H, are like our last example 4, but this time it says flowers are purchased to put on tables at a reception. The head table needs to have 12 flowers, and the other tables need to have 6 flowers each. So I wrote the basic information. Flowers are purchased. The head table needs 12 flowers, and the other tables need 6 flowers each. Okay. So G says write a rule to model the situation. So here's my general rule. All right. And what I need to know is A1 and I need D. Those are the first 2 things I need to find. And it turns out that A1 is right here because the head table, which is table number 1, is 12. And then every other table will need 6 flowers. So our common difference this time, our common difference will be 6. All right. I have those listed here. And so my general formula, A to the n, is equal to 12 plus n minus 1 times 6. All right, so there's my general rule to model this situation. Okay. All right, H says use the rule. We're going to use this rule to find the number of flowers needed for 15 tables. I started to run out of room here, but I made it work. Where n is equal to 15. All right, so a to the 15th is equal to 12 plus 15 take away 1 is 14 times 6. All right, and then I calculated 12 plus 84. We end up needing 96 flowers to cover these 15 tables. And that's all that's needed to do. Hopefully you guys got this on your own. If not, please go back and look at this and redo this assignment. Do this until you understand this, understand these concepts and these terms. All right. You guys have a great day, and thank you for being here.